is exactly right.
Step into the world of audio entertainment with Audible, the home of storytelling. With Audible, you can discover thousands of podcasts, from popular favorites to exclusive new series. And as an Audible member, you can choose one title a month to keep from their entire catalog. Whether you're out for a walk, doing chores at home, or on a road trip, the Audible app is easy to use so you can listen anytime and anywhere. My latest for my dog walks is Human Acts by Hong Kong. It's incredibly powerful, and I highly recommend it. New members can try Audible free for 30 days. Visit audible.com/thispodcast or text this podcast to 500-500. That's audible.com/thispodcast or text this podcast to 500-500 to try Audible free for 30 days. Audible.com/thispodcast.
Are you wasting money on subscriptions? 80% of people have subscriptions they forgot about. Help is here with Rocket Money, formerly known as Truebill. The app shows all your subscriptions in one place and then cancels for you whatever you don't still want. Rocket Money can even find subscriptions you didn't know you were paying for. You may even find out you've been double charged for a subscription. To cancel a subscription, all you have to do is press cancel, and Rocket Money takes care of the rest. Get rid of useless subscriptions with Rocket Money now. Go to rocketmoney.com/Wondery. Seriously, it could save you hundreds per year. That's rocketmoney.com/Wondery. Cancel your unnecessary subscriptions right now at rocketmoney.com/Wondery.
The case was under the care of Dr. During in Philadelphia, by whom it was diagnosed clinically as a typical example of chronic scrofuloderma. By his courtesy, I received a portion of the diseased tissues, but was unable to demonstrate the presence in it of the tubercle bacillus. In the course of the examination, however, numerous curious bodies were found distributed here and there throughout all the sections. They presented the appearance of parasites, and the discovery rendered the case one of peculiar interest. Unfortunately, the matter could not be followed out as closely as could have been desired, as no more material could be obtained, the patient having been operated upon and the whole lesion having been removed. 3 months after our first brief report, Otto Busse published a case in which apparently similar bodies were demonstrated. Still later, other observers have found lesions in animals, horses, guinea pigs, etc., in which very similar bodies have played a pathogenic role. But the present appears to be the first recorded case in which they have given rise to pathological processes in man. In reporting the case before the American Dermatological Society, I expressed the opinion that these bodies, in all probability, would be found to belong to plant rather than to animal life. And further examination appeared to verify the conclusion that they might be classed as Blastomyces.
I'm so curious to see where they went after that.
I mean, blastomycosis, baby. They named it eventually. So that is from T.C. Gilchrist, 1896, in a report titled "A Case of Blastomycetic Dermatitis in Man." Ooh. And it was the first clinical description of what we now know as blastomycosis.
I love it.
Yeah. Just go to the OG source.
Straight to the source. Why not?
Yeah. Hi, I'm Erin Welsh.
And I'm Erin Allman-Updike.
And this podcast will kill you.
And today we're talking fungus.
We are.
Uh-huh.
We haven't done this often.
Not in a while, yeah.
Yeah. I'm excited by that.
Me too.
It's going to be a good one. And I think that blastomycosis is strange. And I am especially curious about the current research.
Oh, yeah.
Yeah.
Me too. I am excited about it because we haven't covered a lot of fungi. I don't feel like they get enough attention.
They don't. And many papers that I read started out that way.
Yeah.
Medical mycology is an overlooked field.
It really is.
Despite the large burden of disease that
Agreed.
pathogenic fungi, whatever, etc.
Oh, so let's fill in that etc. today, shall we, Erin?
Yes, let's do it.
But first, it's quarantini time.
Yes. My favorite time. What are we drinking this week?
We're drinking Blast from the past.
I mean, there were so many quarantini name options with this one. Blast. I'm sure that our title will have Blast in it at some point or another.
Probably. We'll find out.
Yeah. But I liked Blast from the past too, because as you'll hear in the history section, I'm going kind of way back.
Love it.
And I'm excited about it.
Are we going in deep time again, Erin?
I don't know what the exact definition of deep time is, but it feels pretty deep.
Okay, cool.
Let's get into the recipe somehow.
Oh, yeah.
I really derailed this.
What's in a Blast to the past, Erin?
It is so delicious. It's kind of a take on like a bourbon smash, but instead of bourbon, it's rye whiskey. And we're doing peaches and ginger beer, of course, lemon juice, and basil.
Oh, so yum.
It's really refreshing and delightful.
You can find the full recipe for that quarantini and our non-alcoholic placebo-rita on our website, thispodcastwillkillyou.com, and our social media.
Now for website stuff. There's lots of things. I have the website right here, fortunately. So let's just go through some of these tabs. Well, we've got the sources for each and every one of our episodes. We've got links to our bookshop.org affiliate account, our Goodreads list, our merch, some pretty sweet merch there. We've got links to music by Bloodmobile, Patreon, submit your firsthand account form, transcripts, and stuff about us that we probably should update.
We probably should, actually.
Yeah.
Someday. Okay, then. Any other business that we should deal with?
I don't think so. I think that we should just dive right into the episode.
Okay, let's take a quick break and get into it.
Fall is right around the corner, and you're probably already wondering how you can fit all your favorite activities in and eat wholesome, delicious meals. With Factor, you can. Factor is America's #1 ready-to-eat meal kit. With chef-prepared meals delivered right to your door, you can skip the trip to the grocery store and skip the chopping, prepping, and cleaning up too, while still getting all the flavor and nutritional quality you want. Each week, Factor gives you the option to choose from more than 34 flavor-packed, fresh, never-frozen meals, and they're all ready to eat in just 2 minutes. Factor's lunch-to-go options, like grain bowls and salad toppers, can help you keep your energy up and give you something to look forward to during the workday. I love not only the convenience of Factor meals, they are such a time saver, but they're also so delicious, like the sun-dried tomato chicken. Head to factormeals.com/thispodcast50 and use code thispodcast50 to get 50% off. That's code thispodcast50 at factormeals.com/thispodcast50 to get 50% off.
Exposed Cover-Up at Columbia University, the new podcast from Wondery and Dr. Death host Laura Beale, tells the story of the women behind the case against Dr. Robert Haddon. At first, Dr. Haddon seemed like the kind of OBGYN you recommended to your best friend. Calm, knowledgeable, and greeted everyone with a smile. But his cheerful demeanor hid an ugly truth. Dr. Robert Haddon was found to be a serial predator who abused hundreds, potentially thousands of patients over his decades-long career. Once these stories began to see the light of day, one question remained. How was this physician, who was trusted with the lives of so many, able to get away with this for so long? And when the powerful institution he worked for was confronted with these accusations, did it choose to protect its own reputation? Listen to Exposed on the Wondery app or wherever you get your podcasts. You can listen to Exposed early and ad-free on Wondery Plus. Get started with your free trial at Wondery.com/plus.
blastomycosis is the name of the disease caused by the fungus Blastomyces dermatitis, which I looked up how to say like 100 times, so hopefully that's right.
I mean, the spelling of it, I was like, this must be a typo. I kept being like, there are way too many I's and T's here.
And I's and T's and D's and I's.
Yeah.
Blastomyces dermatitis. The other major species is Blastomyces gilchristii, which you said that firsthand account came from Dr. Gilchrist himself?
Sure did.
Okay. There's a story there. Sorry.
History over.
And blastomycosis is a disease of so much more than just humans.
Mm-hmm.
This is a fungus that has been found causing disease and death in humans, but also canids, including wolves and coyotes. And from what I read, it's estimated that in like our domestic dogs, infection rates are likely 8 to 10 times higher than what they are in humans. So we'll come back to that eventually. But also in sea lions, dolphins, ferrets, lions, bears, lemurs, bats. This thing has been around the block.
It's fascinating. I was going to say it's cool, but like...
Ooh, interesting choice of words because it's a thermally dimorphic fungus. Oh.
Which I had to look up what that was.
Yep.
And now I'm like, there's a whole world of these. Why did this evolve? This is fascinating.
I know.
Yeah.
So this is a characteristic of some of the fungi in the phylum Ascomycota. And this basically means that these fungi exist in different states or different forms depending on the temperature, the ambient temperature, and other factors as well. But in the environment, Blastomyces exists as a mold, like the mold on your bread or your cheese, kind of. If you looked at it under the microscope, it would have these long filaments that are called hyphae. And this form, this mold form, reproduces asexually by making these things called conidia, which are spores, that can go out and disperse long distances. So the way that we get exposed to blastomyces is via these spores, the conidia, sometimes directly from the hyphae if like little bits get broken off and we inhale them when they're aerosolized with soil particles.
Mm-hmm.
Or less commonly, we can get inoculated with the spores or the hyphae in our skin if we get a scratch from, say, like a plant or something.
Ooh.
And then what happens is that we, humans, are generally much warmer than soil. And in the warm, wet gooiness that is our body environment, this fungus transforms into a budding yeast. Yeast being a unicellular type of fungus, like the kind that you make bread with, except it's not at all like your bread yeast. And so that's what it means to be dimorphic. It has this yeast form that exists inside of us or inside of hosts at higher temperatures and a mold form that exists in the environment. Coccidioidomycosis that we covered on this podcast is also thermally dimorphic.
Great pronunciation.
Thank you. I practiced. As is histoplasmosis, which I'm sure we'll cover eventually.
Mm-hmm.
And it turns out quite a lot of fungi of medical importance are thermally dimorphic. And it's not only temperature that triggers this dimorphism. It's also things like how much carbon dioxide they're exposed to, which of course is much higher in our lungs than in our air. So once we inhale these spores and they're inside of us, they get eaten up by macrophages, which again are one of our white blood cells that are good at gobbling things that don't belong in us. And then they do this transform into yeast thing and start budding, as a yeast does, in order to make more of itself. That's the way that it reproduces. And what's so fascinating is that in this process, during this transformation into yeast, what this fungus starts to do is upregulate all of these genes that, like, why do they have these genes? These genes that are specifically good at evading our immune system. So these are things like adhesins and calcium binding proteins and outer wall glycoproteins, all of these boring names of things that basically help this yeast stick to our cells and actively evade our immune defenses.
It's amazing.
It's so cool. So all of these genes are doing things like inhibiting major cytokines that we use in our defense, like TNF alpha. We'll come back to it. And inhibiting the activation of our T lymphocytes. Like, it's incredible what this yeast, this fungus, is able to do.
Yeah.
And when they do this, on top of all of that, they also have to rearrange all of their cell walls. And in doing this, in this transformation from hyphae to yeast, it's yet another way to further confuse our immune system and make it harder to block this infection.
Okay, I love this, and I can't wait. Like, this ties in so well with what I'm going to be talking about.
Yay!
I'm excited about it. About it.
Me too.
I feel like this is going to be much more of a mind-blowing episode, I hope, or at least it was for me, and it is right now in hearing you talk about it.
Oh, good.
Than I ever thought a fungal infection could be.
Now I'm like even more excited for the history section. Wow. But so that is one of the things that makes blastomycosis specifically not considered just an opportunistic infection. A lot of fungal infections we think of as mostly being a problem for people who have various degrees of immunocompromise. And it's definitely true that for people with things like deficiencies in their T cell function, for example, in advanced HIV or AIDS, or people who are maybe on TNF alpha inhibitors, that important cytokine, those people are potentially at much higher risk of severe infection, but this is a fungus that can infect all of us. So it's fascinating. It turns out that it's about 50-50 whether you actually are going to have symptoms from exposure to blastomyces.
Okay.
And that is a little more than I expected for a fungus.
Yeah, like, how has that number been calculated with, like, is it just from known outbreaks or known exposures?
I think so. Good question.
Okay.
Yeah. My guess is yes, it's from like various studies where they've tried to actually look at, you have an outbreak and then you try and look at a larger population. How many people do you find infected that never had symptoms?
Right. Who might have been at the pond near the rotting wood that day also.
Exactly. And when it comes to symptoms, there are two main classes of symptoms. There's pulmonary and there's extrapulmonary, aka everywhere else in your body. And like many fungal infections, this is a slow-growing pathogen. So symptoms can take anywhere from 3 weeks to 3 months or more to develop after exposure.
Okay, so I have a question, though, because and maybe this is just because I was reading older papers, but I thought that the environmental sources of Blastomyces dermatitidis they haven't been super well characterized, and it's not reliably isolated from the environment. So how do you know if an exposure was 3 weeks ago or 3 months ago?
That's such a good question, especially if you're living in an endemic area.
Right.
I don't think we know.
Okay.
Because also 3 weeks and 3 months is a very wide range.
Yeah, it's very wide.
So is the range really that wide, or do we just not know that well?
Right. It's like, well, I think 3 months ago, I guess I went camping there, but but maybe you forgot about something that was not camping that could have been an exposure. Okay.
And maybe we have slightly better data from people who go to an endemic area and become exposed and then leave that endemic area and then have symptoms later.
Okay.
But yeah, you're right. A lot of this is a little bit messy. As you'll see, we don't have the answers.
Yeah. We're so not used to that on this podcast.
It's never happened before. Oh, yeah. So let's get into what this disease looks like when people are symptomatic. So for those 50% of people who are going to show some kind of symptoms, over 80% will have some type of pulmonary infection. Because again, most of the time we're being exposed by inhaling spores or inhaling hyphae. But even this pulmonary infection can be very broad in terms of symptoms. For some people, it's a relatively minor pneumonia. For others, it can be as severe as acute respiratory distress syndrome that can lead to death. So in the case of more mild infections, like just a run-of-the-mill pneumonia, we're looking at things like fevers, you might have chills, a cough, some difficulty breathing, chest pain. These are symptoms that are easy to confuse with any other kind of community-acquired pneumonia. And when we look at an X-ray, it's usually pretty indistinguishable from that perspective as well from any other bacterial cause. There's nothing that makes a Blastomyces pneumonia stand out necessarily. And that is one of the first problems, right? Because that's going to make it a lot harder to diagnose. And so because of this, a relatively minor pneumonia can easily progress to a chronic pneumonia that just kind of persists because it's not going to be treated with whatever antibiotics somebody might take. Or it can progress to an acute respiratory distress syndrome, or ARDS.
And can it spontaneously resolve?
It's a good question. I don't know.
Okay.
Yeah. So on the chronic end of things, it could certainly be very mild symptoms for a long time. This is something that can mimic tuberculosis or even lung cancer. And so a lot of times those diseases might have very long periods where the symptoms are mild enough that people might not, seek care in that way, or maybe not have access to care. But I didn't read anything about like spontaneous resolution necessarily.
Okay.
If you progress to the point where you're having symptoms.
Right. Yeah. Okay.
Yeah. It's a good question. But yeah, so in a chronic infection, people might have night sweats. They might have some weight loss, a persistent cough. They might even progress to coughing up blood or hemoptysis. But again, even in this case, the X-ray findings are not very specific. They can look like cancer. They could look like tuberculosis. So unless somebody has a very clear risk factor, like working construction in the Ohio River Valley or something like that, or the diagnostic team thinks to check for blastomycosis, which is more likely to happen in an endemic area than in a place where blastomycosis doesn't exist, it might take months before the correct diagnosis is reached in those cases. But the scary part is if it progresses to acute respiratory distress syndrome. And this is something that can happen even just after an acute pneumonia within a few weeks and has the potential for a greater than 50% mortality rate.
Even with treatment?
I think even with treatment, because it can be so rapid, if it progresses in this direction, not a 50% mortality rate for just a chronic infection, but if it gets to the point where you basically have your lungs filling up with fluid because of how much inflammation there is, then yes, it's a 50% mortality rate. Because as we'll see, treatment for fungal infections in general and blastomycosis specifically is really prolonged. It takes months and months of antifungal treatment to clear this infection.
Mm-hmm.
So that's the kind of pulmonary syndrome of blastomycosis. But of course, this fungus is among us. I was really trying to throw that in there somewhere.
It's very well shoehorned in right there.
Thank you. Just made it work. It's not limited to our lungs. Because once these blastomyces transform into their yeast form, our bodies have a really hard time doing anything about them. And so then they can just disseminate either through our bloodstream or through our lymphatics and just cause disease theoretically anywhere, but there's a few places that tend to be the most common. So the second most common place of infection outside of the lungs is the skin. 40 to 80% of people that have disseminated disease, so any disease outside of the lungs, have some type of skin manifestation. And these can vary a lot in what they look like, but they're often fairly gnarly. They can look like these like nodules. Sometimes it's like a purplish nodule or like a plaque, which is like a large, several centimeter wide kind of circle raised on your skin that can progress to like an ulcer or even an abscess. And they can continue to progress to these very large necrotic or completely dead tissue lesions that can lead to permanent scarring if they're not treated.
Yikes.
Yeah. And after skin, the second most common site of dissemination is our bones. And this can happen either directly from a skin infection that then just kind of makes its way into the bone, or it can just go from your lungs straight to the bone through your bloodstream.
How does something go into our bones, Erin?
I mean, lots of infections can go into your bones. Your bones are a living thing.
I remember, was it tuberculosis episode? I can't remember. But like,
that sounds right.
Why? How?
Yeah. Well,
why?
How? I think why is a more interesting question than how, because how is just like, oh, it's our bloodstream. But why? Like, why is it so good at getting into our bones when other infections aren't?
Exactly.
I don't know. It's a good question, though.
Wow.
But this is not uncommon. About 5 to 25% of cases of disseminated blastomycosis can cause an osteomyelitis. And then this, once it's in the bone, can then extend into our joints or into the soft tissues like muscles and ligaments and result in a septic arthritis or deep, deep abscesses.
So the lesions are an indication of disseminated disease, regardless of whether it's just one lesion or lesions all over your body.
Excellent question. Most of the time, yes, it is possible to have just a skin infection if you got exposed via inoculation in the skin. Mm-hmm. That is possible, but it's much less common. Because pulmonary infection is so much more common, overall, it's more likely that there was a pulmonary infection that made it through the bloodstream and then made it to the skin, even if there's only one skin lesion.
Okay.
Yeah. It's a good question. Beyond our skin and our bones, the two other places that are most common, and again, why? Such a good question. I don't know. But the two other places that are most common to see blastomycosis infections are the genitourinary tract, and this means any part. It can be an epididymitis, it can be a prostatitis, it can be an endometritis, it can be cystitis, which is your bladder. So this is just literally any organ involved in the genitourinary system. And then there is the central nervous system infection. So that's brain and spinal cord. And this can happen either from bloodborne spread crossing over that blood-brain barrier, or from an osteomyelitis, so a bone infection in the skull that then progresses. Sorry, your face does not like that mental image.
Gosh.
I know. And as with many infections that we've talked about that can infect our brain or our spinal cord, the symptoms here can really range. They can be a headache, they can be confusion, they could be any range of neurologic deficits like seizures or visual disturbances. It's a really, really wide range of potential nervous system symptoms.
These different routes that a disseminated infection can take may or may not be affected by antifungals. Like whether or not it progresses to central nervous system involvement. Like, can you stop that? Or is it like, oh, we didn't know what this infection was. Suddenly now there's central nervous system involvement. Someone goes to the doctor and they're like, well.
Yeah, that's a good question. I don't have like an exact answer for you. I can say that overall, the case fatality rate based on studies in hyperendemic regions is about 4 to 6%. And most of those likely had pretty severe infection, either widely disseminated in multiple organs or a central nervous system infection, or just a very bad ARDS, or acute respiratory distress syndrome. It's not that it's impossible to treat if it's a disseminated infection. It's just that this is a difficult pathogen to treat regardless of where the infection is. So if it's already disseminated, you're likely dealing with a much larger fungal load that you have to deal with.
Right.
And the drugs that we use to treat fungal infections, namely amphotericin B, especially if it's a severe infection, or various forms of conazoles like itraconazole, these are not drugs without their own sets of risks. They can be pretty hard on the liver, pretty hard on the kidneys, have a lot of drug-drug interactions. So yeah, this is a disease that's difficult to diagnose and then difficult to treat, especially depending on how severe it's gotten to begin with.
Yeah.
Yeah. And while this is a disease that can infect and does infect immunocompetent people with a fully functional immune system, in people with various degrees of immunocompromise, the risk of severe infection and the mortality rate can be significantly higher. In some cases, as high as 40% in people with poorly controlled HIV or AIDS, or people with a history of a solid organ transplant who are often on a lot of immunosuppressive medications. So that's the biology, Erin, of blastomycosis.
This is a scary.
I think one of the things that makes fungal infections the most scary to me personally is how difficult they are to diagnose early.
And how little we seem to know about their inner workings.
Right. Yeah. Because, the early infection is usually pulmonary and usually looks like pneumonia until somebody gets really sick.
And so this was sort of, I guess, going back to that question about pneumonia. Let's say that you are feeling sick, you think you might have pneumonia, you go to the doctor. What are the next things that happen? And then when is there exhaustive testing? Like, do people test until they find a pathogen or until someone gets better?
Oof. That's like a question about the whole American healthcare system, isn't it?
It had to
no
be, didn't
pressure.
it?
I mean, it's going to really depend. I'm thinking more about your question that you asked on could you clear this infection on your own? And I feel like the answer has to be yes for some people, because these case fatality rates in studies that we see are 4 to 6%, presumably what we know of how many people get infected is likely a great underestimate.
Yeah.
So presumably, yes, there are people who get infected, maybe even get treated with antibiotics that don't do anything for their fungal infection, but then they slowly get better. And in fact, their body took care of the blastomycosis infection itself. Presumably, I guess. But to answer your actual question, which was like, are we testing for this? It really, really is going to depend. It's going to depend on what part, in the United States at least, which is where the vast majority of cases of blastomycosis are. Spoilers for the epidemiology section. It's going to depend on what part you live in. If you live somewhere where this is a known endemic disease, it's more likely that if someone is not getting better with normal antibiotics, that they're going to test for this infection. It's less likely perhaps in other areas. I think the biggest thing that will improve detection overall is more and more PCR-based testing, because in any kind of PCR-based testing, you can test for a whole bunch of different pathogens all at once.
Right.
Right now, it's mostly culture that's still the gold standard, and that takes potentially weeks to be able to grow this fungus in culture. There are urine tests that we can do, like we do for Legionella, that look for the antigen, like that look for various antigens of Blastomyces. But those are imperfect tests as well. So yeah, it really just depends on how sick somebody is, on where they are, on how much access they have to what kind of healthcare system. and how much people are thinking fungal infections versus not, etc.
Oh, it is, this one is more intense than I thought it would be.
It really is, isn't it?
Yeah.
So, Erin, where did this fungus come from?
Yeah. Let's take a quick break and then I'll get into something.
Okay.
I want you to picture Steve Jobs tinkering with a computer in his garage, Walt Disney drawing cartoons for his high school newspaper. Every big moment starts with a big dream, but what happens when that dream turns out to be an even bigger failure? Each week on Wondery's new podcast, The Big Flop, host Misha Brown is joined by different comedians to chronicle some of the biggest failures and blunders in pop culture history. Each episode will have you thinking, why in the world did this get made? From box office flops like Cats the movie, to Action Park, New Jersey's infamous theme park that had countless injuries, many lawsuits, and rides so wild it became known as Class Action Park. Or Quibi, that short-form video platform with an even shorter lifespan. It's a story of a spectacular failure with lots of surprises along the way. Enjoy The Big Flop on the Wondery app or wherever you get your podcasts. You can listen to The Big Flop early and ad-free on Wondery Plus. Get started with your free trial at Wondery.com/plus.
Erin, this is our 125th episode.
Oh, I didn't know that.
Regular season episode.
Oh, wow.
Like not including COVID or bonus episodes or anything like that.
Okay.
Yeah. First of all, congratulations to us.
Oh, pats on the back.
Mm-hmm. But yet, somehow, I tallied it up. This is only the second fungal pathogen of humans that we've covered, right?
We did coccidioidomycosis. And what fungus did we do of non-humans?
We did white nose syndrome in bats.
That's right.
And we did a chytrid episode.
Oh, yeah, chytrid.
And then in our zombies episode way back, we talked about cordyceps a bit.
Yep, just a little bit.
Just a little bit. But this is only the second time, I'm pretty sure.
I think that you're right. And we've been talking about doing another fungal episode for a while, but I think if we had done that mental math, we would have been like, whoops.
Yeah,
and
whoops.
done it sooner.
Whoops, indeed. But yeah, like maybe it's because I haven't gotten to think about fungi as often as I should. But researching blastomycosis got me thinking about fungal pathogens as a group, like human fungal pathogens as a group, and why this is only our second episode on a human fungal pathogen. And it's not because we don't like fungi or find them interesting. Like we've talked about how psyched we are to like research this and talk about it. But I think that it really has to do more with the number of known fungal species that can cause disease in humans, whether that's through an environmental fungus invading our tissues, like an accidental pathogen, or an opportunistic pathogen, or through a part of our microbiome growing out of balance, like dysbiosis. And that number of fungi pathogenic to humans pales in comparison to the more commonly featured stars of this podcast, bacteria and viruses. And then I started to think about like why that is. Partly, it could be that fungal pathogens have received less research and less media attention compared to these other groups, and that the global burden of fungal infections in humans is actually an underestimate, which of course it is. But it's certainly not because the parasitic life cycle is unfamiliar to fungi.
Yeah.
Of the 2.2 to 3.8 million estimated species of fungi on this planet, about 270,000 are thought to be pathogenic to plants, and about 50,000 are thought to be pathogenic to insects. Compare those numbers to the few hundred, like we're talking hundreds, that are pathogenic to humans and other mammals. We're not in the thousands.
Is it temperature?
Well,
okay.
Let's get into it.
Let's.
So in the first half, it's actually like way more than half. The history of blasto is very small. So I got way too excited about this part. I wanted to ask two primary questions, or try to answer two primary questions. Number one, what is it about humans and other mammals that keeps us mostly off limits from fungi? And number two, what's up with those special few fungi that do infect humans? How do they do what they do?
Yeah.
The answer to the first question is pretty straightforward, and you hit it right on the head. It's temperature. Well, it's actually twofold.
Okay.
It's temperature being a big one. We're warm-blooded as mammals. We are endotherms is the technical term. And number two is our immune systems in general just do a really good job of protecting us from systemic infections, largely through like macrophages, right? And other parts of our immune system. But what I really want to spend more time talking about today is our warm-bloodedness, our endothermy. One of the key features of mammals as a group, and birds, but I'm not going to talk about birds, so sorry to all of our bird nerd friends out there. But mammals maintain body temperatures at a constant rate, and we do this through producing our own heat using metabolic processes. This is called endothermy. And that constantly maintained body temperature tends to be warm relative to the environment. And since the vast majority of fungi are adapted to living at environmental temperatures, for instance, in soil, we mammals are simply too hot to handle. If endotherms are on one end of a spectrum of strategies for regulating body temperature, at the opposite end are ectotherms, so-called cold-blooded, because they rely on environmental sources of heat, like the sun, to adjust their body temperature. Reptiles, amphibians, fish, all examples of ectotherms. Although, again, it's a spectrum, and I have to mention that some species fall in between these two extremes. Like some fish, I learned, have regional endothermy, where they can maintain temperature in certain regions of their body, like their brain areas.
That's why they can swim really fast even when it's really cold.
Yep.
And really long distances. Fish are cool.
Fish are really cool. Yeah. Or some mammals are more ectothermic than we tend to think of mammals, like the 13-lined ground squirrel or bats that drop their body temperature when going into torpor or hibernation.
Okay, cool.
But generally speaking, ectotherms are more susceptible to infection from fungal pathogens because their body temperatures more closely match the environment at least part of the day. It's not as much of a stretch as it would be for most fungi infecting endotherms. Unless, of course, you're a fungus infecting a bat who's in torpor, like we talked about in our episode on white nose syndrome. Right? Yep.
I remember that now.
A paper from 2009 looked at thermal growth tolerance for several thousand fungal strains, basically how well they can grow at a range of different temperatures, and found that as you increase temperatures above 30 degrees Celsius or 86 degrees Fahrenheit, fewer and fewer strains can hack it in the heat. Just having these warm bodies alone helps to protect us from fungal pathogens, which is a pretty awesome superpower.
Yeah.
But it's one that comes at a cost. Endothermy is super energetically expensive. And I mean super. It takes a whole lot of energy to maintain body temperature. And to keep up with that high rate of energy consumption, endotherms have to take in way more food, like 10 times at least that of an ectotherm.
Wow.
Yeah.
That's why I'm always hungry.
I know, right? That's why, yeah. And we endotherms can't go as long without eating compared to most other ectotherms, with some endotherms needing to eat every hour, otherwise they risk death. Meanwhile, some ectotherms can forego food for over a year. It's
wow,
incredible.
Huh.
So for such a costly trait as endothermy, there's got to be a big payoff or payoffs. Pays off. I don't know which one. I think it's payoffs. Like cul-de-sac.
Cul-de-sac.
Yeah. And the leading hypotheses for the rise of endothermy, which I've seen estimates that it emerged between 100 million years ago to 250 million years ago. But these leading hypotheses can be grouped into three primary models. Number one, thermoregulation. That maintaining constant body temperature, even as the ambient temperature fluctuates, would have allowed early endotherms to be active at all times, giving them an advantage on a number of fronts, right? You can expand your range into colder areas where ectotherms don't thrive as well. You can shift your behavior to being like nocturnal to avoid the reptilian predators that are more active during the day. And even this thermoregulation may have allowed our brains to grow larger and more complex since they're being constantly fed that energy. Number two, enhanced aerobic capacity. Endotherms can be more active over longer periods of time, giving them an edge if, for instance, a small endotherm was trying to escape from an ectotherm predator, many of which are sit-and-wait predators. And who also didn't have the ability to sustain that kind of long-term activity. Or maybe it helped an endotherm predator chase after its endotherm prey. Endotherms just have more energy stores than ectotherms for aerobic activity. Number three, parental care. Endothermy evolved because it allowed parents to incubate their developing young at a higher temperature, and then the enhanced aerobic capacity helped them to defend their offspring and collect food for them, increasing their survival.
That's a fun one.
Isn't that a fun one? Yeah.
I like that.
And I feel like I've said this for the past 3 episodes now as I go into like deep time and stuff that's not really related to like the history of germ theory somehow. I'm really loving this. Like, I hope that
it's been really fun.
People like this. Yeah. I'm actually having so much fun talking about like these principles of what makes us human or viruses or anyway. Okay.
All of it.
But this, like I've said for the past few episodes, is an area of ongoing research. It's an active area of discussion. And it's probably an interplay among these drivers that led to the emergence of endothermy. And we may never know the full story. We probably won't. But there is one more hypothesis, not a leading one necessarily, that has been mentioned here and there, which is that endothermy arose because higher body temperatures helped prevent infection with fungal pathogens.
Wow.
Okay. So, like I talked about in our last episode on the drivers of color vision in humans and other primates, this is another chicken and egg scenario. Did fungi drive endothermy, or was escape from fungal infections just this added perk of endothermy? And there's not much by way of like fossil physical evidence for the former, but I did stumble upon some papers that laid out a scenario where the latter, escape from fungal infections, helped to usher in the age of the mammals.
Okay,
Yeah.
I'm listening.
For nearly 20 years, a researcher of microbiology and immunology named Arturo Casadevall, along with some colleagues, has been working on a hypothesis called the, quote, fungal infection mammalian selection hypothesis.
Ooh, okay.
Around 66 million years ago, the Earth witnessed one of the largest cataclysmic losses of life, the Cretaceous Paleogene Extinction event, when a massive asteroid slammed into the Yucatan Peninsula. And I feel compelled to mention that this is a hypothesis still, but there's pretty strong evidence that it was indeed an impact that coincided with I don't know how much that's like a contentious issue. I don't think it is. Anyway, that's just like
all of our toddler dinosaur books still mention it as like a hypothesis. Right. But they're also like from my childhood, so they're kind of old.
When like Brontosaurus was still a thing. Is Brontosaurus still a thing?
Yeah. No, Brachiosaurus is a thing. Brontosaurus is not.
Oh, see?
Yeah.
Like that.
Anyways.
That's how I learned. Anyway, the result of this impact was the die-off of 75% of species, including the extinction of all non-avian dinosaurs and, of course, enormous ecological collapse. This is familiar territory. The oceans acidified, the skies turned dark, forests burned and died off, photosynthesis didn't occur for 1 to 2 years. The planet went into a cooling period of at least 9 years, and much of the planet was basically turned into a giant pile of decomposing biomass.
Sorry, no photosynthesis for 2 years?
I've seen estimates from 6 months to 2 years, but most recently 1 to 2 years seems to be.
Wow.
Yeah.
Wow. Okay.
And so the end result of all this is that there was just a ton of dead things all around.
Yeah.
The planet was turned into a giant pile of decomposing biomass.
Wow.
And what loves decomposing biomass? What thrives on decomposing biomass? What puts the decompose in decomposing biomass?
Fungus.
Exactly right.
Ooh.
And research supports this. A huge fungal peak has been observed following that asteroid impact, like around that same time, and it would have lasted a few years.
Oh my God, I'm loving this so much.
I'm so glad. But it would have been an incredible amount of fungi.
Oh, wow.
The remaining ectotherms would have had a hard time regulating body temperature since the sun was blotted out by dust clouds and the entire planet was experiencing this substantial period of cooling. And that cooling also would have skewed the sex ratios among reptiles.
Oh my gosh.
Right? I never thought of that.
Me neither.
Ugh. Things were already not looking great for these guys.
Okay.
But then when you throw fungal proliferation into the mix, bad news.
No good.
Worse news, the worst possible news.
Yep.
The already struggling and probably malnutritioned ectotherms wouldn't have been able to raise their body temperature to induce fever to fight off a fungal infection since the sun was hiding. And the eggs that they laid would have also been susceptible to the ever-present fungi. Side note, apparently fossilized hyphae have been found in fossilized dino eggs.
Oh, that's cool.
Isn't that? Casadevall argues that this fungal bloom and its impact on ectotherms helped to pave the way for mammals to take over.
What?
Because endotherms would have fared much better in this global calamity. Being able to regulate body temperature would have protected them as the planet cooled and allowed them to move around more to collect food. And having embryos that developed inside you would have protected them much more from fungal diseases.
I have to say, I have gone through a lot of museum exhibits about dinosaurs and this extinction event and read a lot of dino books. And they always just mention like, and then the mammals mostly survived. And like, nobody talks about why. And this is amazing.
Isn't it? I love this. I think it's been so fun to read about. And I will say that, like, of course, I have to say, this is a hypothesis, number one.
Yeah.
Number two, a lot of things were going on, right?
Yeah.
Like even if you didn't have the fungal bloom, not being able to like warm your body temperature enough to go find food would have been
a problem.
Not great.
Mm-hmm.
And then, there's a lot of stuff that I didn't want to go into about sort of the relationship between endothermy and ectothermy and body size and like what is in terms of efficiency, in terms of like food intake. So like there's more under the surface there, but things were happening that somehow led to ectotherms starving and dying potentially from fungal infections, where endotherms just sort of prospered or were able to make it work. I'll say that.
Ugh, so cool.
And I don't know enough about this time period or the research in this area about what sort of led to the rise of mammals, especially not enough to say whether this is a well-regarded hypothesis or whether this is like, I don't know, has a lot of support or not. But I do think it's really fun and interesting to think about, especially since I feel like ecological research tends to, even today, neglect the effect that parasitism and infections can have on entire ecosystems.
100%.
Like, unless you are a disease ecologist or a parasite ecologist and you're studying that thing directly.
I agree. So, future episode, we're going to talk about how did crocodiles survive, okay?
Yeah. I don't know. Good question. I love it. I'm going to have to do a lot more reading. I'm excited about it. I have a book about dinosaurs I've been meaning to read for like the longest time.
Here's your chance.
Completely forgot I have on my shelf. Yes, now's my chance.
Okay. I love this. The fungus is why we exist. That's what I'm taking away from this.
Oh, gosh.
I'm just kidding. What an interesting idea, though. I love it.
It's just really fun to think about. And I want to know if someone is out there who knows more about this or is just like, hey, I thought that was really cool, let us know.
Yeah.
And
please.
Also, I have a lot of sources to post about this. So if you want to do some more reading, have at it. Okay. So we endotherms are more protected against fungal infections thanks to our warm bodies and specialized immune systems.
Okay.
But we're not completely protected, obviously. Otherwise, we wouldn't be doing this episode. So what is it about those select few fungi that allow them to wreak havoc on us with 1 billion superficial fungal infections, 135 million mucosal fungal infections, 23.3 million allergic fungal infections, and several million chronic and acute invasive fungal infections every year, with more than 1.6 million deaths annually?
Whoa,
right?
Erin, that's massive.
Right? I mean, it's bigger than I ever thought. These fungi that are causing this massive global burden of disease, are there commonalities among them, among the species causing disease? One feature of many, but not all, fungal infections lies in their opportunistic nature. Most of the time, we see fungi causing secondary infections or primary infections in people who are immunocompromised, or we see these like accidental pathogens like Blastomyces dermatitis. Rarely do we encounter fungi that are obligately pathogenic, right? Like most fungi don't need a human host to complete their life cycle. It's just that these fungi pathogenic to humans, whether opportunistically or accidentally, possess traits that help them to succeed in their natural habitat. For instance, tolerating higher temperatures because it allows them to expand where they live. And some of those traits also happen to help them colonize a human or other mammalian endotherm host. And because of this, human pathogenicity evolved many times across many lineages of the fungal tree of life. But is it that human pathogenicity evolved? Or is it that these traits evolved because they give the fungus a competitive edge in their natural habitat? And they also happen to be the same traits that help the fungus infect humans. And the answer is it depends. And maybe it's like a more of a semantics thing. Like,
okay,
they might be able to be both. So there are a handful of obligately intracellular fungal parasites, Microsporidia, that probably co-evolved with their hosts. But most of the known human fungal pathogens fall into the opportunistically or accidentally pathogenic category. Blastomycosis being one of these as like an accidental pathogen. So let's think about what types of traits would help these fungi thrive in their natural habitat, say soil, which would be overflowing with microbial diversity, both competitors and predators. One thing I already mentioned was thermotolerance, being able to survive at higher temperatures. That would help them maybe find food in a less populated area or escape from predators or pathogens who aren't as thermotolerant. Then there's the ability to adapt to varying levels of oxygen, which could be helpful for the same reasons. Maybe a fungus is great at evading amoeba, which are common predators in soil environments.
Ooh.
And if a fungus can escape amoebae, then maybe that helps it evade macrophages in the human host.
I love that so much, Erin.
Right? And then finally, reproduction. Blastomyces does this thing that you talked about, Erin, where it switched from filamentous to yeast growth when in a human host, and that helps it evade host immune responses. And so I think it's so fascinating to think about these pathogenic traits in fungi because it forces us to recognize that they don't play by the same rules as the pathogens that we're used to, namely viruses and bacteria. And that could have bearing on how we treat these infections and how we assess risk. Understanding the ecology, like the natural ecology in these ecosystems, in soil, for instance, of these medically relevant fungi also gives us opportunities to develop new antifungal treatments by examining like what other microbes or microbial products have an impact on this fungus's growth. Right? If within a teaspoon of soil, there's a full-on battle royale of microbes, like who's winning? Who is releasing products that are knocking down Blastomyces? What's eating Blastomyces? What can Blastomyces not escape from? Maybe Blastomyces isn't the greatest example because we don't know its precise ecological niche, but you get the idea. Speaking of Blastomyces, I guess I should finally get into the history of this specific fungus.
I want to hear all about it, but I'm having so much fun already.
Good. Well, there's not much, at least that I could find in terms of the evolutionary history of Blastomyces as a genus. I read somewhere that the most recent common ancestor of the Onaginalis order, which Blastomyces belongs to, that this most recent common ancestor emerged 150 million years ago. And I also read that Blastomyces dermatitidis and Blastomyces gilchristii diverged about 1.9 million years ago.
Okay.
Yeah, that's all I got for that. And the prehistory of Blastomyces is similarly sparse. But I did come across a paper from 1978 where researchers studying the Shield Mississippian Cemetery in Illinois, which is a prehistoric site, suggested that blastomycosis may have affected the community that they were studying based on evidence from skeletal remains ranging from 1 to 2,000 years old or so.
Huh, okay.
Yeah. I mean, and it does fit with what we know about the distribution of blastomycosis in North America. But it also, according to the authors, could have been tuberculosis, which, like you said, they're commonly mistaken for one another. Regardless, cases of blastomycosis probably occurred in at least the eastern half of North America long before dermatologist Thomas Caspar Gilchrist identified the fungus in a tissue sample from an infected individual in 1894. Basically, kind of what you heard in our first-hand account. At this time, the medical field was still sort of like, it had been a few decades since germ theory had been introduced, but it took people a lot longer to recognize that fungi can be pathogenic to humans or other animals. And blastomycosis actually was one of within a span of a few years, the first that had been identified as causing disease in a human.
This is a silly question, but in the late 1800s, did they know that a fungus was a fungus? Because I feel like he called it a plant in the first-hand account. So
I don't know about the full breakdown of the taxonomy of fungi at the time, but I know that fungi weren't really separated out into their own kingdom until later. And so they were grouped in with plants. And it wasn't so much fungi were thought to be plants as it was that it was animals and not animals and everything else.
Okay.
And so I think that splitting happened later on. But in the later paper by Gilchrist, which just within a few years when he found a second case, he did draw the fungal cells and the fungal structure and stuff like that. And so I think that it was well recognized to be a fungus. It was just thought to be a type of plant.
Yeah. That's interesting.
Yeah. Also, in that firsthand account, he mentioned that he thought it was a parasite in the very beginning, but later he was like, no, this is definitely a plant. And then that's when he named it, drew pictures of it, all of that. And he named it Blastomyces dermatitidis. And so really within the first few decades, first half of the 20th century, other physicians reported an increasing number of cases of blastomycosis in the Midwest U.S., with the highest number of cases in Chicago, which gave rise to the nickname Chicago disease. So you'll find that in some of the older literature on blastomycosis. Researchers also recognized that Blastomyces dermatitidis could cause respiratory and systemic infections, infect other animals besides humans, including dogs, and was not the exclusively North American disease they thought it was. With blastomycosis cases reported in Central and East Africa and India and probably other places that we just haven't found it yet. But it kind of reminds me of the tularemia episode in that way, where it was this is the Chicago disease.
Yeah.
Not quite.
Actually.
And Erin, I know that in a few minutes you're going to bring us up to speed on blastoepidemiology around the world today. But I don't think it'll be a spoiler to say that this isn't a super prevalent disease, right? But it can be, as we learned, a very deadly one, even with effective antifungal drugs. And I did find somewhere that prior to the introduction of drugs like amphotericin B, which you mentioned, the case fatality rate for chronic pulmonary and disseminated infection was 100%. And part of what contributes to the deadliness or the apprehension surrounding blastomycosis is that its ecology still hasn't been fully resolved. Epidemiological studies suggest pretty strongly that the fungus probably resides near rotting wood and fresh water, but people haven't been able to reliably isolate it from environmental sources, even when there's a recognized outbreak or cluster. And this represents a pretty major challenge in understanding or quantifying risk factors for this disease, both in the present day as well as in the future. Because if there's one thing that we know for certain, it's that this is an environmental fungus. And as an environmental fungus, its growth, survival, distribution, and exposure to humans and other animals, that's all influenced by changes in its environment. Changes like climate change. Earlier in this history section, I talked about how our endothermy may have been mammals' saving grace during the Cretaceous Paleogene extinction event, when we could maintain high body temperatures to fend off fungal infections. But what happens as the global temperature continues to rise? selecting for fungi that can withstand the heat of this warming planet and thus our warmer bodies.
Uh-oh.
Will we see more cases of fungal infections or more fungal species that can cause infection? Well, Erin, what do the experts say? Where do we stand with blastomycosis today?
Oh, I can't wait to talk about it right after this break. So like you mentioned already, Erin, one of the problems when it comes to understanding this fungal pathogen is that we don't. We don't really even yet know everything about its ecology. We do know that it seems to reside and thrive in damp, sandy soils with an acidic pH, if you care about that part, where there's a lot of rotting wood, often near lakes or rivers or other waterways. The vast majority of cases and most of what we know about blastomycosis comes from the United States. And specifically, this is a pathogen that's endemic in soils across the Midwest, the Southeast, the East, and a little bit in the South Central US and up into Canada, classically described on like med school tests as the Ohio and Mississippi River valleys and around the Great Lakes and another river that I forgot to write down. St. Lawrence, I think.
Just some river in Canada. We don't care.
It goes through Canada and like another part of the U.S. Wow, Erin. I thought New England was a state for a long time.
It's not?
Yeah. But like you mentioned, cases have also been found across a very wide swath of the massive continent that is Africa, as well as in India. Overall, the reports across Africa and in India have been very rare. Less than 10 cases confirmed in India and about 100 cases across 18 different countries in Africa, which is not a lot.
Mm-hmm.
Most of these cases, both in the U.S. and in the other parts of the world where cases have been reported, tend to be sporadic, though there have been some occupations or situations that have led to some outbreaks in the past, like construction situations, hanging out in beaver dams, apparently.
Huh.
Yeah, that was reported. There was an outbreak. It was small. But part of the problem is that in the U.S., where this is most common, blastomycosis is not a reportable disease across most of its distribution. It's reportable right now in Arkansas, Louisiana, Michigan, Minnesota, and Wisconsin. But the rest of its distribution, it's not considered a reportable disease, so we don't have a lot of data on it. 2019 was the last year that an MMWR report came out from the CDC. And in that report, they cited a total of 240 confirmed or probable cases of blastomycosis across the U.S., which resulted in 147 hospitalizations. So that's a pretty high rate of hospitalizations compared to the number of confirmed cases.
Yeah.
Yeah. There are several regions in North America that tend to be hyper-endemic, where the overall incidence rate each year is significantly higher than in the rest of the area where it still can happen. Those places include part of Ontario, where caseloads can be as high as 117 per 100,000 people per year. In Eagle River, Wisconsin, and Vilas County, is that how you say it? Wisconsin,
sure,
where cases can range between 40 and 100 per 100,000, and a few other areas as well, but those are the biggest ones. And I would be remiss not to mention that there is an outbreak that happened this year in 2023. The most recent data I have on it is from April, But by that time, at least 100 people had gotten sick and one person has died in an outbreak of blastomycosis at a paper mill in Michigan. That is the largest outbreak by far in a very long time, and apparently the first outbreak that's been specifically associated with like a workplace exposure rather than just like a construction site where it was an environmental exposure.
From the wood that they were processing.
Right, at the paper mill.
Okay.
Yeah.
Interesting. And I feel like doing research on an outbreak like that will probably help answer some of the questions about environmental exposure, about asymptomatic versus symptomatic versus, what's the infectious dose, all of that type of stuff.
Absolutely. Apparently, this paper mill, at least according to the New York Times article that I read about it, employs about 800 people. So that's a lot of people that got sick out of just that many people who work there. I know.
Gosh.
I know. So we'll see how the rest of this comes out. I'm sure there'll be a lot of papers that come out of this outbreak.
Yeah.
But that's kind of what we know about the epidemiology of this disease. It's not a lot. There is seasonality to it. There tends to be highest case numbers in autumn and in spring, meaning that during the colder winter months, I don't know if it's just because people aren't outside as much or because the fungus is just not as active and maybe there's not as many spores in the environment. Who knows? But there tends to be less infection during those colder winter months.
Okay.
And then that's when we have to come to how is this all going to change in our warming planet?
Yeah.
Yeah. The short answer is that we don't know, but we do know that undoubtedly there will be changes, right?
Of course.
Because this is an environmental pathogen, it is inevitable that the climate and weather conditions influence the growth and the dispersal of Blastomyces. We have seen in the past that there have been outbreaks, much like with coccidioidomycosis, after you have a period of rainfall and then a dry period, right? Thinking that after you have this big rain, you get a lot of growth of the fungus, and then the soil dries out and those spores are able to go on air currents and we breathe them all in. We know that large rainfall events and hotter conditions are things that are going to happen with climate change.
Mm-hmm.
The other thing is that there is a hypothesis in general that these fungal diseases that are already well adapted to mammals, like you talked a lot about, Erin, especially these thermally dimorphic fungi, many of which can infect humans, might be particularly well suited to this new warmer climate because they're already quite capable of surviving at higher temperatures.
Mm-hmm.
So we may see overall rises in this infection, blastomycosis, as well as other similar infections, coccidioidomycosis, histoplasmosis, paracoccidioides, there's a bunch more. We might also just see changes in the range and the distribution where it moves into areas that we hadn't seen blastomycosis before. We don't really know, but it's definitely a huge factor in considering the effects that global climate change have on our health and the health of our animal pets.
Yeah.
And wildlife.
And wildlife and basically everything. I think that's what's so fascinating, I think, about fungal pathogens is that based on my very limited understanding of just doing that research, if you can infect one mammal, you likely can infect all of them as long as there's an exposure route available to you.
Yeah, yeah. So I am sure that like with many pathogens we've covered, it feels like this season especially, we will probably see more and more blastomycosis the more we look for it.
Yeah. Seek and ye shall find.
Exactly. So that, Erin, is blastomycosis.
You know, we haven't really said any what a blast type jokes, but
well, I did have a blast.
You did.
I did, despite it all.
I had a blast learning as well.
Yeah. I mean, I learned a lot about just how mammals exist. I'm just kidding, but kind of, but not. You know?
Well, if you too would like to learn more and keep having a blast, I don't know. It's late. I'm tired. Let's do sources.
Sources.
I have a lot, like I said. I'm going to shout out 3 in particular, one for each of sort of like the themes that I covered in the history section. So the first is by Casadevall and Damon from 2020 called Updating the Fungal Infection Mammalian Selection Hypothesis at the End of the Cretaceous Period. And then in terms of the traits in fungi that help make them pathogenic to humans, there's a paper by Rokas from 2022 called Evolution of the Human Pathogenic Lifestyle in Fungi. And then finally, for the history of discovery, there's a book by Aldori and DeSalvo from 2012 called Blastomycosis.
I had a few different papers. There's actually some really great overviews. One that was more broad about these types of fungi in general called Fungal Dimorphism and Virulence, Molecular Mechanisms for Temperature Adaptation, Immune Evasion, and In Vitro Survival. Loved it. That was a 2017 paper. We'll post that. And then Clinical Manifestations and Treatment of Blastomycosis from Clinics in Chest Medicine, and then just Blastomycosis, an infectious disease clinics paper from 2021. Those were really good, just broad overviews of this infection. And then I have a bunch more about the maps, looking at where we've found blastomycosis, what we think might happen with climate change, and so much more. You can find all of our sources from this episode and every one of the other 124 plus episodes on our website, thispodcastwillkillyou.com.
Thank you to Bloodmobile for providing the music for this episode and all of our episodes.
Thank you to Liana Squilacci for the incredible sound mixing.
Thank you to Exactly Right.
And thank you to you, listeners. We hope you had a blast.
There surely has to be more blast puns or idioms out there that we can use.
I can't do it.
No, not at this point in the night. But yeah, thank you so much for listening. And a huge, huge thank you, as always, to our wonderful, generous patrons. We really just appreciate you so much.
So much. Thank you.
Well, until next time, wash your hands.
You filthy animals.
Listen, follow, leave us a review on Amazon Music, Apple Podcasts, or wherever you get your podcasts. Hey, Prime members, did you know you can listen to This Podcast Will Kill You early and ad-free on Amazon Music? Download the Amazon Music app today. You can support This Podcast Will Kill You by filling out a survey at Wondery.com/survey.